Hello, calculus students and general seekers of truth. Welcome to the video on examples with parametric equations and particle motion in 2 dimensions. So we're given a problem here that for a time interval 0 to 4, a particle's position, okay, this is its position that we're talking about here, is given by this set of parametric equations. The x is changing with respect to time according to sine of pi over 2t, and the y is changing with respect to time according to this formula. Okay, so these two functions tell us how to locate the particle, and I've typed this into my TI-83 graphing calculator. Make sure I am in radian mode here, and I graphed it, and this is what the path of it looks like. You can see here that when t is equal to 0, it's at the top there, and it actually moves to the right, and then down, and then to the left, and then back to the right a little bit more. So to give you a sense, this right here is the path that the particle is taking, and as t increases, this is the direction that it's moving in. Okay, and now we want to answer some of these questions regarding the particle motion. So A, what is its position at t equals 1? Well, that's straightforward enough. All we have to do is take 1 and substitute it in for t. So its position is sine of pi of 2, comma, 2 cosine of pi of 4, pi over 4. Okay. And I'm putting parentheses here. So this is a coordinate that I'm calculating here. And, you know, sine of pi over 2 is 1. And cosine of pi over 4 is root 2 over 2 times 2 will give you root 2. And we can confirm this on the calculator. So if I type in trace 1 for t, you can see that the x-coordinate is equal to 1, and the y-coordinate is 1.14, which in fact is root 2. Okay. B, what is its velocity vector? Now, these two parametric equations give me the position at any time, and if I want to find the velocity vector, well, remember that velocity is the derivative of position. Okay. And so if we want to find the velocity vector, we just take the derivative of both of these functions, of the function for x and the one for y. Derivative of sine of pi over 2t is pi over 2 cosine pi over 2t. Okay, so don't forget to use and to apply the chain rule. Derivative of 2 cosine pi over 4 is negative sine pi over 4 t. Then you have to multiply by the 2 and multiply by the pi over 4. So working all that out, we get negative pi over 2 sine of t. And I'm putting the square or these angle brackets in here because this is a vector. Okay, so this vector describes the instantaneous velocity at any given moment in time. If you want to know what its velocity at a certain time, you plug in that number into t, and this will tell you. Okay. C, what is its acceleration vector? Well, this is pretty straightforward as well. Remember that acceleration is the derivative of velocity. Okay. So we take the derivative of the velocity function, and this will give us negative pi squared over 4 sine of pi over 2t. And here we are going to get the negative pi, it's going to be pi squared over 8 cosine of pi over 4 t. And again, this vector gives us the acceleration. Acceleration, much like velocity, also has direction. You accelerate in the x direction and in the y direction. Okay? So moving along pretty nicely. D, what is its velocity and speed at t equals 1.5? Well, we already have, when something asks for its velocity, we are talking about the vector because this object is moving in two-dimensional space. So its velocity at 1.5, we simply take 1.5 and substitute it in for t. And I'll write all this out. This gives me pi over 2 cosine of pi over 2. Now 1.5 is 3/2. And then negative pi over 2 sine of pi over 4 times 3/2. Okay. Hopefully your trigonometric skills are pretty sharp. And we can see here that you have pi over 2 cosine of, this is 3 pi over 4, which is negative root 2 over 2. And then here you have negative pi over 2 times the sine of, and this is 3/8 pi. Now there are some trig identities that we could use to find the exact answer, but that's really not the focus of this video, so I'll just leave it like that, and then I will give you the decimal approximation using your calculator. Okay. So negative 1.111 and negative 1.451 makes up the velocity vector for this particle at time t equals 1.5. Now to find the speed, and remember the speed is simply the magnitude of the velocity. So the speed is equal to the square root of negative 1.111 quantity squared plus negative 1.451 quantity squared. And this gives me that the speed is approximately equal to, oh, that should not be a negative number. Speed is always positive, so that should be approximately 1.828.